Today we will discuss about the proving of irrationality. Proving of irrationality. Proving of irrationality. So previously we have heard root 2 is an irrational number, root 3 is an irrational number, root 5 is an irrational number, root 7, root 11, root 13 and so on. So now we will prove today the irrationality. So let us see. Let prove root 3 is an irrational number. Root 3 is an irrational number. What? Root 3. Now this we will prove by the method of contradiction. Method of contradiction means we have to assume one thing which is wrong. We have to assume a wrong thing right. Then we have to prove that no. We have taken the wrong thing right. So our result is wrong. So I will explain it one by one. What? So this will be proved by the method of contradiction. Method of contradiction. So now let root 3 is a rational number. Let root 3 is a rational number. So root 3 is equal to P by Q, where Q is not equal to 0. P and Q are positive integers. Now if P and Q have some common factors, let's say P by Q is equal to 6 by 10, that is equal to your 3 by 5. We know P by Q should be expressed in its lowest term first. So by reducing it into its lowest term, we will get A by B, that is equal to A by B. Now your P by Q is equal to 6 by 10 and A by B is equal to 3 by 5. Now we will write root 3 is equal to A by B, where A and B are co-prime. B is not equal to 0. B is not equal to 0. Co-prime means A and B do not have any other factor common other than 1. So now see, A and B do not have any other factor common other than 1. A and B co-prime. Here I am giving one star mark. Why? I will explain. Where A and B are co-prime means A and B have only one common factor, 1. Now we'll see root 3 is equal to A by B. Now 3 is equal to A square by B square, squaring both sides. 3 is equal to A square by B square. That implies 3B square is equal to A square. That implies B square is equal to A square by 3. b square is equal to a square by 3. Now, according to theorem, when the square of a number is divisible by a factor, then the number itself is also divisible by that factor. According to theorem, let 100. Take one example. 100 is divisible by a is equal to, let's say a is equal to 100 is divisible. A square is, let's take a square is equal to 100 is divisible by 10. Now a is equal to root over 100 is equal to 10. We are not taking minus, positive integers. So 10 is also divisible by 10 is also divisible. 100 is divisible by 10. So a square divisible by 10. So 10 is also divisible by 10. Now a is divisible by 10. So according to the theorem, when the square of a number is divisible by a factor, then the number itself is also divisible by that factor. Now, when a square is divisible by 3, a is also divisible by 3. That means 3 is a factor of a. 3 is a factor of a. Now let a by 3 is equal to some result is equal to c. That implies a by 3 is equal to c. That implies a is equal to 3c. That implies a square is equal to 9c square. Squaring both sides. A square is equal to 9c square. Now see, a square is equal to 9c square. Now here a square is equal to 3b square. A square is equal to 3b square. That implies 3b square is equal to 9c square. That implies b square is equal to 3c square. Cancelling the common factor rule, b square is equal to 3c square. That implies b square by 3 is equal to c square. B square by 3 is equal to c square, which implies b square is divisible by 3. So b is also divisible by 3. Now here we have taken, see the contradiction, we have taken a and b do not have any other factor common other than 1. When a and b are co-prime, HCF of a and b is equal to 1. We have taken HCF co-prime, HCF a and b is equal to 1. So when HCF of a and b is equal to 1, we we are getting A, 3 is a common factor. B, 3 is a common factor. That means 3 is a common factor for both A and B. So here 3 is a common factor for both A and B. So 3 is a common factor for both A and B. What we have taken? What we have assumed? A by B co-prime, but we are getting A by B are not co-prime because they have a common factor 3. They have a common factor 3. Now recalling it. Now take root 3 is equal to P by Q. A by B, A, B are. We have taken root 3 and rational number. Now A, B are co-prime. We are getting 3 is a common factor. So now just listen mindfully. Visualize. Now the contradiction. Now that contradicts the assumption. That contradicts the assumption. But this contradiction has arisen because of our incorrect assumption that root 3 is rational. Hence root 3 is an irrational number. Now see, again revisiting. Let's root 3 is an irrational number. So root 3 is equal to P by Q. Q is not equal to 0 in form. Now P by Q reduced to the form of A by B. A, B are co-prime, and H of A, B is equal to 1. Now root 3 is equal to A by B, and now here B square is equal to A square by 3, so A is divisible by 3. Now you are getting, again taking A by 3 is equal to C, we are getting B square by 3 is equal to C square, so B square is divisible by 3, B is divisible by 3. The 3 is a common factor. Here 3 is a common factor for both A and B. And when 3 is a common factor, but we have taken A, B are co-prime, HCF is 1. So that contradicts the assumption. The contradicts as a reason because of our incorrect assumption that root 3 is rational. Hence root 3 is irrational. Now if you will thorough about this proving of root 3 is an irrational number, you can prove root 2 is an irrational number, root 5 is an irrational number, root 7 is an irrational number, root 11 is an irrational number, root 13 is an irrational number, root 15 is an irrational number. So many numbers. You try to solve it by your own by following these are the steps and this theorem. So now we will move on to the next question. Say there we will discuss about one example. So in the example we will prove the same thing by taking the method of contradiction. That means we have taken a wrong thing and finally for that assumption we are getting a wrong result. So now so that 5 minus root 3 is an irrational number. So now same method contradiction. Method of contradiction. Let 5 minus root 3 is a rational number. That implies 5 minus root 3 is equal to, let a by b comma b is not equal to 0, where a by b is form of rational number a comma b elements to I. Positive integers we are taking here. Now that implies 5 minus a by b is equal to root 3. 5 minus a by b is equal to root 3. That implies 5b minus a by b is equal to root 3. So if a and b are integers, then 5b minus a is also a integer. B is an integer. Hence 5b minus a by b is a rational number. Is a rational number. We have taken is rational number. Here is a rational number. This is a rational number, but here is root 3. So that implies root 3 is rational. When 5b minus a by b is a rational number, that is equal to root 3. So root 3 is rational. Which contradicts the assumption. Which contradicts the assumption. This contradiction has arisen because of our incorrect assumption that what 5 minus root 3 is a rational number. Hence 5 minus root 3 is irrational. Thank you.